All right, so first of all, how many of you have read any of the Left Behind books? All right, I'm a huge fan of this book series. Now, you could make the argument whether or not it's, the biblical soundness of it, but at the very least, I think it was a Christian fiction novel, group of novels that at least got people thinking about the right stuff. I think that's at least a fair statement. Now, I don't know, 2000 or something like that, the stupid Kirk Cameron movies came out, whatever, and they were at least okay. They were in the same, they seemed to follow the movie. Well, this movie last Friday just started, starring Nicolas Cage. Just assume you're going to sell tickets, right? Now Left Behind, the original series, is a 13-book series. Book 1 covers a lot of crap. For those of you who read the book, the ending of this book was the ending of the movie was the airplane landing. That happened, I went back and looked at the book, that's 8% into the book. This movie had nothing to do with the book except character names. Even the wrong people disappeared. It was so bad. So the Christian worldview side of this is this. So you look back and you see these guys writing these novels, Jerry B. Jenkins and Tim LaHaye. One of them's like a biblical scholar, the other one's an author. And these guys made buku bucks off this book series. I'm relatively okay with that because the product that they came out with, I think, did more good than harm in the Christian community. Well, they gave 2 big thumbs up to this one. I'm sure for a payday. So where I have a problem is the whole chasing the almighty dollar type thing, and I'm not sure that really fits into a Christian worldview. I mean, this movie was a bad B movie, even if it had nothing to do with the book. Fine, bad B movies come out all the time. But the fact that these authors who had already made a bunch of money off the Christian folks, that baby. is that somebody's baby?
Oh, it's just wall.
No. having a rough morning. So, in any case, the fact that he'd already made so much money off this, to publicly give 2 thumbs up to something that was based on their book, that literally had nothing to do with their book. And I can almost honestly say it had nothing to do with their book. I mean, the wrong characters were in the wrong cities. So in the book, the daughter is stranded out somewhere. Now, she helps this plane crash land. In the movie, the plane didn't crash land in the book. The co-pilot in the book has like a recurring role throughout the first couple books before he's finally killed. No, he disappears right at the beginning of the movie. Complete garbage. This is an example of people taking advantage of the Christian community, because that's who was going to go and see this movie, right? People who are fans of the book, and this isn't going to compete with whatever the blockbuster that's currently out is. The only chance it had was because Nicolas Cage was in it. But it makes you feel taken advantage of, that they drug you into this movie thinking they were going to give you something that was like crap, but at least followed the movie, or followed the book rather. So I don't know. Don't go and see this. Write hate letters. It's complete garbage. So I've lost all respect for these authors.
So what are you saying? You want us to not see it and then write hate letters?
Correct. To the authors.
And say, I didn't see it, but...
Yeah, so the big rant here actually has little to do with the movie. There's bad movies that come out all the time. It's more to do with these authors that, claim to be good Christians and write all these Bible study things and stuff like that. Just feel very taken advantage of by these guys that, you somewhat look up to as a, good Samaritans in the Christian community or something like that. Just terrible.
The moral of the story is form your own opinion.
Just terrible. In fact, you know what?
Overall, you give it a 5 out of 10?
What's up?
Overall, you give it a 5 out of 10?
0 out of 10.
6 out of 10?
No. And actually, if you go on to Rotten Tomatoes and read all the critics, I would say the average rating was a 1. Some of the things I looked at, lots of people specifically said, our system wouldn't allow us to give it 0. It didn't know how to fill in 0 stars.
3.4 on IMDb. 3.9.
Out of 100? I'm actually interested in something. let's see, Tim LaHaye net worth. Isn't there a net worth? Here, I misspelled his name. I figured they'd be on the net worth. Jerry Jenkins. See, there's a good website called Celebrity Net Worth, this guy, where you can go and like look up people and find out how much money they're actually worth. It's always interesting because people are worth more or less than you actually thought they were. All right, let's do Tim. Okay.
Still made $7 million.
Do we get a number? How much is it? Oh, MC Hammer. This guy's probably worthless now.
Yeah, he gets sued.
On Flickster, it's got 2%.
2%?
The Rotten Tomato thing, 2%.
It's probably,
Yeah, whatever. I was trying to look for what these authors have made.
The movie made $7 million.
I think it had a $15 million budget. Hasn't even made half of it back yet. Even bad movies typically make 2 or 3 times budget. Nah, they're not going to tell us. These guys probably are worth $20 million. Complete garbage. Complete.
And rant.
Huh?
And rant.
And rant. If you haven't read the books, which I do recommend you read the books, they are good. But if you haven't read those and you want to get a feel for what the books are sort of kind of like, go and watch the 2000 movie with Cameron, or what's his name? Kirk Cameron. Yeah, Kirk Cameron. It's not a good movie, and it's only a mediocre rendition of the book, but compared to this, it might as well be the book. All right, zoom. Can I get one more? Aha. All right, so let's power through this slide set because some of the stuff is going to be review, and then we get to process management. Okay, so operating systems provide an environment for execution of programs and services to programs and users. One set of operating system services provides functions that are helpful to the user. So we have a user interface thing. One thing you might see online, specifically if you've ever done anything with PHP, you see something called PHP-CLI. That's the command line interface for PHP. So you can actually run PHP commands from the command line. So that's the command line interface, little shorthand graphic user interface, or GUI. Let's see. Okay, that's waste. We talked about interprocess communications, more than one program talking to each other in some way. So this comes into, we didn't talk about the specifics of it, but just the existence of this. If you have more than one thread of execution running at once and they're reliant on another one finishing, they have to have some way of communicating with each other. So that's where interprocess communication comes in, and we'll have a whole section on that. Error detection, we've seen it more modernly in Java and other languages through exception handling, right? So most programs that are running at the operating system level know how to raise flags, or it's actually called signals, where they let the operating system know that something happened. Sometimes the somethings that happen are bad somethings. So that's another responsibility of the operating system. Resource allocation, we've talked about that. The operating system has to make sure so-and-so gets, we're all competing for the CPU, we're all competing for memory, we're all competing for the hard drive, blah, blah, blah. Accounting, which users use how much of what kinds of computer resources. An interesting Unix command related to this. If you want to get kind of at a glance look at what's happening on the computer right now is a command called top. And this shows you the things that are currently using your system resources on the computer. So if I look through this, bash, this is the actual the shell thing I'm running right now. Top is the command that's at the top of it because that's what's in the foreground. Some Apple stuff. Then it gives us kind of load average up here. CPU usage. Now keep in mind, I am currently recording, screen capturing, running how many applications? I have all these applications open on my computer right now. I'm using 1.5% of my CPU.
Plus the system.
Hmm.
Plus the 3%.
Oh, fine. But this is the user. This is just using idle cycles in the background. And remember, the operating system has a goal of keeping the CPU busy 100% of the time. So we're at less than 5% of the time, while we're sitting in front of our computer using it. So kind of an interesting thing. So this is the more interesting number. So our CPU is sitting there 94% idle. That's while we're using it, constantly capturing the video of what we're doing right now in audio, because I'm screen recording right now. So there's your evidence that don't spend all your money on your processor. Better places to spend your money. Okay, then it gives your memory usage and all this other stuff. So in any case, kind of gives you some interesting information about what's going on in the computer. This is bash, born again shell. The early thing was called SH. So this is like the original Unix shell called SH. And it didn't support, actually this is a pretty upgraded version of SH. Something we take for granted now with our Unix shells is that we can press up and go back to the previous commands, things like that, where historically we used to have to go and look at the history of commands you put in, and if we wanted to redo this command, let's say, you would do #277 like that, and it would open it up, rather than being able to push up to get the stuff. So these are old things. So even the fact that they have SH on here, it's not even really SH, is kind of stupid, I think. But in any case, accounting, being able to go back and see what was going on in the system, typically at the time of a crash. So when a server goes down, a lot of times you want to know why it went down. Was this an attack? Was this an individual user? Was this a bug in a program? Let's say you had a user using a program, and all of a sudden you notice that the user was using CPU time at a normal level, but the memory was going crazy. So because the program might have had a memory leak, that kind of stuff. Protection and security, obviously, that's something the operating system's in charge of. But we talked a little bit about when we talked about Windows Vista. That was really the big failure point of Vista, was that it was inconvenient for the user. So there's that, you got to strike that balance between overtly protecting the user. I mean, we're okay if the operating system wants to protect us to the really armor clad us underneath the hood so we don't see it. But when it starts going into the way we're using the operating system, like with Vista, every 5 seconds it was popping up saying, "Are you sure you want to do this?" You said yes, and you say, "Are you really sure?" When it's asking you twice about whether you want to do the same thing, it's problematic. But certainly one of the responsibilities of our operating system is protecting us. But the other responsibility is giving us an easy user interface and a convenient way to use the computer, so sometimes those are in conflict. In fact, something we'll see in here is that there's a lot of conflicts like that within the operating system, kind of picking that balance between what the end user wants and what the end user really needs. And this becomes even a bigger issue in multi-user operating systems like Unix and server-type operating systems. But Unix is a good example because that might be something where you have multiple people using the machine at the exact same time. Who do you try to make happy? In a single-user operating system, Windows, Mac OS, whatever, the job is to make the person sitting in front of the screen and keyboard happy. or at least, we'll convince them they're happy. Whether they're as happy as they could have been, immaterial. As long as they think they're happy, we're fine. But what if you have an operating system that has 30 people using it simultaneously? Who are you trying to make happy? Or what if you have the super user on there? Should he be happier or less happy? So you have all sorts of interesting dilemmas to go through as you're programming an operating system, deciding, who do we give priority to? Is it always first come, first serve? In real life, it's first come, first serve, but in the computer world, maybe not. Maybe that's not what makes sense. So kind of a interesting thing. We've kind of seen this chart like this before. This adds just a couple of layers in here. We have, the graphic user interface and the command line at the top. We have user interfaces that connect to our system calls. Underneath the hood, then you have program execution, I/O operation, file systems, communication, resource allocation, and accounting. Below that, we have error detection and protection and security. And this is all services that sit above the actual software that's the operating system, which then sits right above the hardware. All right, so really when we think about our operating systems today, it's a suite of programs that serve a whole bunch of tasks. They do a whole bunch of things, I guess. Command line interface allows direct command entry, so things like this you've seen me doing. My guess is at least many of you have never done something like this. Is that a true statement? Probably at least roughly. And that's not so much that you suck, it's more the time you grew up in. Historically, if you were a Windows user, which were obviously far more popular than Mac users, even today, but before the Windows graphic user interface was there, and even in the early days of Windows, you had to launch Windows. So your computer would boot into DOS, and then if you wanted to go to Windows, you type in WIN and press enter, and it would launch Windows, launch the program that was the graphic user interface, because the actual operating system was DOS. That's what was running all that stuff. Windows, what we call Windows, was actually just a program, and still is, that ran on top of DOS. Today it runs on top of the NT kernel, which is the newer version of DOS from, remember we talked about that, where we had the business line and the consumer line, and all of a sudden they merged. But in any case, the early days PC users would have been very familiar with command line stuff because they would have done everything from that. Even the early Apple users, early Apple computers ran DOS. They ran the same operating system as PCs ran, but they just ran it on a different architecture. PCs have been running on Intel architecture since really the beginning. Where in the early days of the Apple computers, they branched over to what eventually became the PowerPC processors. It was just a small company doing RISC processors, reduced instruction set stuff. But in any case, doing stuff out here from the command line used to be commonplace. So the question is why do I still do some stuff from the command line like this? Is there value in doing this?
Sometimes you don't have to go do a bunch of other things.
It can certainly be faster, but there's tools that you can do out here that you can't accomplish in a graphical user type interface. So let's say that you have, there's not that many files in here, but let's say I'm just interested in the files that start with a B. I can do ls pipe to more, first of all, which will give me everything on the screen one at a time. I could do ls pipe to grep BL, and that'll just give me the stuff that starts with BL. Now I can put those commands inside of a program. So I can actually write shell-based programs that will do all this automated stuff for me. And those are things that we, to this day, don't really have a good way of doing in the graphical user interface. The Mac has something called Automator, which allows you to kind of build utilities for doing multiple things in your computer at once, where you're saying click this, then do this, then do this, then do this, and maybe you have it run every so often or something like that for like doing backups, for example. Let's say that you had a necessity to take all your stuff instead of using Dropbox or something like that. You took all of your stuff and backed it up to an FTP server twice a week. Well, what you can do is you can build an automator that takes you through those 5 or 6 steps to do that, and then ultimately upload to the FTP server. So you spend 15 or 20 minutes kind of getting it right the first time, building your automator the right way, and then from there it just works. Another interesting thing that I'm sure none of you will be interested in is, how when you download your illegal crap, sometimes you have to do some stuff to it before it's usable. If it's a video, sometimes you first need to run it through a PAR program to rebuild any errors that it might have, and then you have to convert it into a different video format to watch it on the whether it's iTunes or watching on your Xbox, however you're watching it. You need to have it in the right video format. If you don't specifically have the codec to watch it in, whatever. There's sometimes things that you have to do. Or, for example, let's say you're downloading MP3s and it comes into a little folder, but you need to take whatever's in that folder and you want to dump it into your iTunes account so it's all in one big place. What you can do is you can build an automator to go and do those steps for you. So at the end, you just double click in the automator and it does all that for you and without any problem. So kind of an interesting thing that Automator does. I'm pretty sure Windows has an equivalent type product. I don't know if Microsoft releases it. I think there's a couple of products that are out there that try to mimic it. But none of them are actually very good. They're all very limited because you got to think about the problem they're trying to solve. Those problems are trying to mimic human interaction with the computer, right? We see this in a lot of other genres. So, for instance, David and I have run bots for World of Warcraft before. And this is a program that plays a video game for you. Well, imagine having to, so you're sitting there in front of a video game and you're controlling the, whatever. Well, now you're going to write a program that's going to do that for you. But now it has to make smart decisions. So, there's all sorts of automation type stuff, and they're never going to mimic humans. They try to mimic humans as well as possible, although to this day I still stand by that bot plays the mage way better than I can. So that's a true statement. But in any case, automation type programs like this are beneficial, but you're solving a very difficult problem because you're trying to mimic what human beings are doing in terms of clicking on this and dragging this and doing this. And the thing is that when you think about your operating system, those windows aren't always in the same place, right? We drag stuff all over the place. This icon might be here one day and over here another day, just randomly using that as an example. So if you're trying to solve the problem at the easy level, we might say, oh, we're going to double click on this. We're going to double click on that. Okay, well, what if the next week, whatever was there is now a new thing? Are we still double clicking on this, or should it know that we actually still want to double click on that? Ideally, it knows this. But now you have to solve that problem differently. So it becomes a difficult problem to solve when you start taking all that stuff into consideration. So we still go back to our old terminals where we can have one program call another program, send the input into a third program, and whatever.
So what's the difference between an automator and just writing that shell script?
Well, typically Automator is going to allow us to interface with graphic user applications, where a shell script isn't going to necessarily let us do that. Because usually here you're not using graphic user interface applications. You could. So for instance, I'm pretty sure I can launch Keynote or something like that from out here, from the applications folder or whatever. It'll launch. And some of those programs do take command line arguments, but I'm not going to be able to work with them from the command line. So command line does still have a place. But I would say it's a diminishing returns type place, but only a few people use it. There's a good reason why when you install the stock Mac OS, they don't just throw the terminal icon over here on the left, or for some of you the bottom. I think by default it's the bottom. They don't just throw it there. It's not something that the average Mac user will ever use. I see several Mac users out here. How many of you have never opened the terminal on your own? One time I clicked on it, but so it's not a common thing. All right. So these are the programs that run in the terminal, or the terminal, the equivalent of the graphic user interface before we had a graphic user interface was something called a shell. We just looked at the SH, the original shell, and then bash, the born again shell. There's a bunch of other ones I'm actually interested. Is CSH on here? It looks like it is. Yeah, see, this guy doesn't. Oh, it does. TSH. I think it's actually T. Yeah, see this? They have a whole bunch of shells on here. Why? Each of these shell programs has their own programming language associated with them, their own scripting language. So you can go in, you can write a little program that does if statements and all that stuff and executes programs. So you could have a piece of software that you write that conditionally does other things. So kind of an interesting way of using your operating system that really we don't do anymore. All right, so Gooeys are what we're used to. They give us the desktop, the icons, the folders, all the stuff that we can click on and see and all that stuff. So we don't have to deal with the complexity of the command line. Would we say a GUI is a improvement over the command line? Probably in most ways. There are still some conveniences that command lines provide us that keeps them around a little bit. But generally speaking, we prefer GUIs. Oh, see, I was way ahead of this. Born shell command interpreter. I'm assuming this one's talking about bash, so it's actually the born again shell command interpreter. I don't think this is BSH. But whatever. Here's an example of the Mac OS X GUI. We've seen that. All right, so system calls. System calls are typically written in a high-level language. Notice they mentioned C or C++ here. Most operating systems are written in C or C++. Probably today, most operating systems are written in C++, rather than more modern languages like C# or Java. Why do you think that is? So when they just announced Windows 10, and I'm not 100% positive, but about 99.8% positive that Windows 10 was probably written in C++. Why is that? Why would Microsoft write their newest, latest, greatest operating system in C++ as opposed to the programming language that is their flagship programming language, C#? C++ supports inheritance. Inheritance is an object-oriented language thing. No guesses? Well, huh?
You have a lot more control.
Okay.
C and C++.
In what way? Control over what?
Control over just specific things like building packets. I know you can do it in C versus C++. You have a lot more control over.
Well, let's take it down to even a simpler level. Really memory.
Yeah.
C and C++, we have direct access to memory. Where all these newer languages, we're having to go through some sort of middleman. Even C#. You have the little war between the C# people and the Java people in today's world. Java running in a virtual machine, we really have no access to memory, right? Well, C# kind of, sort of, maybe runs in a virtual machine-ish type thing called the .NET Component Architecture. It's pre-compiled, so it runs through the virtual machine-y type thing before runtime. But as a programmer, you lost control because the .NET Component Architecture translates your C# code into Microsoft Intermediate language, which then gets turned into actual low-level language for that CPU. So what happens in there is you can write a program that directly manipulates memory in C#, but the .NET component architecture can filter out the dangerous stuff. In fact, there's even a command, there's a block structure in C# called the Unsafe block structure. It's literally like we write for loops, and sometimes we'll put stuff inside of a try catch, right? There's a block structure in C# called unsafe. It's a keyword. So doesn't that kind of seem like an irony inside your program? You just throw an unsafe block, like this isn't safe. Let's write this. Okay, so you do lose a lot of control with C#, even though you have substantially more control than Java. It might actually be, I say you have substantially more control. You have the perception of having substantially more control in C# than you do in Java. But most of our operating systems are written in these older languages, and these languages were specifically designed for writing operating systems. In many ways, it's why these languages are still the most powerful languages for writing operating systems, but they're kind of the least likely languages to be used for teaching. They have their role, and that role really isn't going away anytime soon. We're seeing more and more video games being developed in like C#. That's okay from a performance perspective. You are running right on the CPU. So that's okay because we're not having to work directly with hardware. We're typically working from a video game, we're working through some sort of device driver, which then talks to the hardware, right? So we're seeing that evolution happen. We're moving video games away from C++ and more into C#, not Java. You wouldn't see games written in Java because they're purely a runtime virtual machine. That's going to kill performance.
Unless you're Minecraft.
Well, Minecraft can probably pull it off. Just because of, maybe the thing is that we're talking simple games versus, like Angry Birds probably could write in Java. Battlefield probably can't write in Java. That type of thing. So I'm not a Minecraft player, but I've seen enough of it to know that Minecraft is closer to Angry Birds than to Battlefield. Make sense? So I can see that. And the purpose of that would be what? Right? Minecraft wants to have it run on every platform. That's a perk. So as long as you're not giving up gameplay, that would actually be a really interesting experiment. I don't know if anybody would actually spend the time or money to do it, but to port Battlefield to Java and just see what that experience would be like.
Battlefield's buggy enough the way it is.
I actually, pick your favorite, whatever. Pick your favorite, game that you don't think belongs in Java. The high level, lots of crap going on the screen, super high, resolution graphics, lots of textures, shadows, stuff that's we're not gonna see 95% idle time on our CPU when those are running. Those types of games. It would be really interesting to see somebody port like a level of one of those over to Java and just see how it runs. It probably wouldn't do as poorly as we suspect it would because of how fast our computers are today. It wouldn't keep up. There's no way they're going to say, oh, well, this is good enough. Because with gaming, nothing's good enough, right? We always complain about something. And every time a new game comes out, I see them do the comparisons. Here's the PC version of the game, the Xbox version of the game, and the PlayStation version of the game, and right next to each other for the same scenes, and they're talking about shadows and different crap like that. Just, I find it fascinating. Yeah, right. What's up with this guy? You can't even tell his lashes apart from each other.
I think half the time it was used when the new consoles came out just to compare them, and now it's just used by the PC Master Race to show, hey, we're better.
The PC Master Race. It's funny how quickly you incorporate that into the sentence. You've used that phrase before. He's a PlayStation guy. The PC Master Race. But do you really not agree with that? Don't you think that the equivalent game on PC is almost always a higher graphic experience?
Probably.
So it just really makes you sad.
No.
You what?
I have both.
Yeah, but you play it on the PlayStation, most of your games, right?
Depends on the game.
At the end of the day, for me, it comes down to whether or not it's a game I prefer to control with a keyboard and mouse, or if it's a game I prefer to control with a controller. I know some people plug their, do their controllers on their PC. I probably wouldn't. If I'm going to use an Xbox or a PlayStation controller, I would rather just sit in my massage chair and play it on my TV through my PlayStation. If I'm going to drag my butt in front of my computer, I'm not going to be using an Xbox controller.
Depends on if it was on sale on Steam or not.
Yeah, but I'm rich. So for a one-time $30 fee, it's not going to translate into the next 6 months of me dragging my butt off my massage chair to go and sit in front of my computer. It's all for those of you who live in dorm rooms, there isn't a comfortable seat, right? So everything's just kind of, your couch and your computer chair are one and the same. Those are the same piece of furniture. Yeah, so I guess that would be a master race comment. You being the inferior.
They refer to them as peasants.
Really?
Yeah.
Oh, I've used that lots of times. One time I was in a Dungeons and Dragons campaign. I know a couple of you are tabletop players, so you'll appreciate this. And I played a halfling paladin that had like a god complex, and he would just refer to everybody as peasants everywhere he went and stuff like that. But you find out later he has like these slave tattoos and he didn't remember from his former life. It was funny.
Is that like you're a mage who refused to use magic?
Oh, that was true. That was another time. Yeah, I used to be like really big into tabletop stuff. I used to go to some of the different conventions. I was one of the dungeon masters that ran the big campaigns for the stuff. I haven't done it in years, but so I probably would suck now. But in any case, there was one campaign I ran where I was a wizard that refused to use magic. So, for those of you who play these kind of wizards, don't have a lot of hit points typically,
No.
and they also don't have a lot of like the skills necessary to hurt people with weapons. They have magic, which I refuse to use. So I was stabbing people with sticks and stuff. It did actually work out really well in the end because we were fighting this, I don't know, like Cyclops or something like that at the end of one night's campaign, and everybody on our group was basically incapacitated. You're just left with me there. I got all these spells that I won't use. So I'm picking sticks up off the floor, and I was we used an older non-Dungeons and Dragons book for some of our crit tables for my guy. I was rolling on the horned tusk table. Kind of like you're running at something like you're an animal. And I rolled back-to-back 20s, and I killed the Cyclops with a stick to the throat as a wizard. It's my shining day. One other time we had to take out this one army, so it was in they were like highly religious people or something like that, so I took one for the team. I actually lit myself on fire. I walked out there like I was some sort of demon. I think demons are bad, Christian worldview. Okay.
You got placed in it.
Seriously. Yeah, so that was funny. So yeah. There were some aspects of that next thing that really can't be discussed on. Trust me, it was epic. All right. How did we get onto that?
PC Master Race.
Oh, that's right. That was your fault. That was your fault.
I tried.
Oh, here we got it. We got API in here. So programming interfaces to services. System calls are typically written in C and C++. They typically work through some sort of application programming interface. Maybe a nice way of calling this is device drivers. There's other APIs on our operating systems besides that, but really device drivers allow us to communicate with our actual pieces of hardware through an interesting but easy to use interface. Operating system APIs, Win32 API, POSIX API for Unix, Java, they're calling that an API. The Java API, it's the Java programming language. It's actually funny. Anybody know of an operating system that actually did try to write itself in Java? Well, the operating system didn't write itself in Java, but a company they released an upgrade to their operating system, and the operating system was written in Java. Doesn't seem smart, right? By today's standards, because we think about Java as being slow, and we think about operating systems as being fast, ideally, correct? Interesting company. Sun. Remember the name of the operating system? Solaris. Solaris operating system. Java OS actually isn't a bad guy. There was a place that made a thing called Java OS, but that wasn't Sun. Sun Microsystems, now called Oracle, they had a well-respected server class operating system called Solaris. And there was when Solaris kind of split, they had before that it was called Sun OS, but when Solaris kind of split, it was when Sun went from having their server class machines, which were all running PowerPC type chips, to reduced instruction set type chips. They were actually called their Spark chips, but they were still reduced instruction set chips. But Spark sounds cool, right? But in any case, then they started having machines that had Intel in it. So for normal folks who wanted to seem cool, they could be running, Solaris workstations made by Sun at twice the price of a normal machine because it was cool. In any case, they came out with an Intel-based version of their operating system, Solaris, and then they released a Java-based one on top of that Intel-based one. So it was still Intel-based, and it had a core probably written in C++, but large chunks of the operating system were written in Java. That did not work out. Java is slow. Don't want that for operating systems. So actually that whole Intel side of Solaris kind of died out. Nobody wants to pay twice the price for a Intel-based Unix workstation. Just, dumb, especially when you can just install Linux, right? I don't know, interesting thing. Why use APIs rather than system calls? What do you think? This is a question that could be applicable to a lot of different things. Could a operating system designer, could they have multiple releases of their operating system that use the same API but change the way the system calls work under the hood? So it's an advantage. So from an operating system perspective, we can keep releasing new versions of the operating system that make things more efficient at the system call level, but leave the same API. Oh, you want to do this? Fine. Call this API call, and it will do that. But the old version of the operating system maybe did it with step A, B, C, and D. The new version maybe just does it with A and C. It's more efficient, but you still made the same API call. Also, now you have programs that continue to run on multiple releases of the operating system, which we rely on. That's a big deal for us, right? If you're going to go out, how many of you would go out and upgrade to Windows 10 if all your software that you currently have running wouldn't run on it? Few of us, right? Not worth it. And remember when we talked about the Mac operating systems, Apple asked their people to do that. When they jumped from OS 9 to OS X, they basically said none of your crap is going to work. It just so happened they had the right type of cult following that people still followed. So YouTube video?
No, PC Master Race stuff.
It's killing me. Okay. So this might be a system call sequence. Inquire input file name, write prompt to screen, blah, 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 blah. All this would be done through an API rather than the crazy looking stuff that would specifically, acquire input file name would be talking directly to the file system. Something like that. If we go through an API, it's going to look a lot cleaner when we write our program. When the person who's writing the operating system, if they're writing it for the API, their code's not going to look like it's alien. So this might be a function call in a standard API. Here's our read file function call, returns a Boolean value. We give it the file handle, the buffer we want to read into, how many bytes we want to read. Is this the bytes that we've already read for an offset is my guess. I have no idea what this last one is. Yeah, number of bytes read during the last read. So in any case, this is kind of documentation like we've looked at with Java. Here's how you call this method. That type of thing. Yeah, so this is what we were just talking about. If you're programming for the API, you just have to obey the API, which hopefully stays consistent through multiple versions of the operating system, and understand what the ultimate result will be from the operating system, not how they accomplish it. Okay? And we see this in cars. We know if we press the gas pedal that the car goes. And I'm sure over the years, you know, when I had my first car, it had a gas pedal. My modern car has a gas pedal, and that gas pedal all makes it go. But I'm not a car guy, but I'm fairly certain that probably some new stuff happens when I press the gas pedal today than what happened when I pressed the gas pedal 20 years ago. Right? Stuff that's happening, but I'm still using the same API. I still apply pressure to gas pedal to make car go. All right, we've really talked about that. Wasted slide. Wasted slide. We just looked at passing stuff to those. Oh my God. We'll actually stop and talk about some of this stuff because passing stuff through a table, that gets into interprocess communication. That's an interesting thing to actually talk about. So I'll stop right here. And I'll see everybody on Wednesday.